So this is CE 340. This is problem 24 from chapter 10. Deals with rectangular channel flow. Here we have the top view of the channel, and here we have the side view. We're given the dimensions of the channel, as well as the flow rate, which is 25 feet cubed per second, and Y1 is 2 feet. We need to find Y2. So we're going to go ahead and start out with the specific energy equation, which is Y1 plus V1 squared over 2G plus Z1, and then the same on the right side, but just with subscript 2's. So first of all, we're given Y1 here. We know that Z1 and Z2 are equal because it's channel elevation, so they can cancel out, and we're solving for Y2. Alright, so since we know the flow rate, which is 25 feet cubed per second, we can go ahead and find V1 and V2. We know that V is equal to little q divided by Y, which is also equal to the flow rate divided by B times Y. So if we go ahead and write that out real quick, we know that V1 is going to be equal to the flow rate, 25 cubic feet per second, divided by B1, which is 4 feet, times Y1, which is 2 feet. That ends up being 3.125 feet per second. And for V2, it gets a little bit harder. That's equal to 25 cubic feet per second divided by 3, which is B2, but we don't know Y2, so you can go ahead and leave this term as just to conserve some space. But what we did was we put the three main things that we've already found. We have the condensed specific energy equation, the V1 value and the V2 value. So what we went ahead and did was plug in for Y1 2 feet. For V1 is 3.125 feet per second. Square that and divide it by 2 times gravity, which is 32.2 feet per second squared. And on the right side of the equation, we have Y2, which we still don't know. We have V2 squared, which is this whole thing right here, divided by 2 times 32.2 again. So if you go ahead and condense this, on the left side you get 2.15164. That's equal to the right side, which is Y2 plus 1.07833 divided by Y2 squared. So what you want to do is have everything in the numerator, so you can go ahead and multiply everything by Y2 squared. So on the left side, you're going to go ahead and have 0. You're going to have Y2 cubed minus the same number squared, and then plus 1.078. So what you can do, you can either use your calculator or a computer to go ahead and calculate this cubic root. And the three roots that you're going to find are 1.829, negative 0.623, and 0.9455. All these values are in feet. And what you can do is go ahead and assume that the value cannot be negative, so you can cross out this second one. And you have to find some way to determine which of these two that you're going to use. Alright, so since we have our two given Y2 values that we calculated from earlier, we know that the third one wasn't going to work because it was negative. You need to create some kind of relationship between the first point in our channel and the second point. So what we're going to go ahead and do is use the Froude number, which is V divided by the square root of GY. To make that comparison, we need to use the values from the first point. So we just went ahead and said the Froude number at 1 is equal to V1 over square root of G times Y1. That number was below 1, so it's subcritical. So what we're trying to do when we're analyzing this is look at the two numbers that we have left and find the other one that is subcritical. So first we went ahead and used the Y2 equals 1.829 feet. So you can find it the same way. It's equal to V2 over the square root of GY2. When you put all those numbers in, you end up getting a value that is also less than 1, which is subcritical. But we'll go ahead and check the other one just to make sure. This Y2 is equal to 0.9455. When you plug all those numbers in, you get a value that's greater than 1.5972. So you know it's supercritical. So what this whole Froude number analysis did for us was show us that we can go ahead and use this value because this one matches this. So the answer is actually going to be Y2 equals 1.829 feet.